Okay, so now this is um, 8.39 amps, 8.39 amps, 8.39 amps, 8.39 amps, 8.39 amps, 8.39 amps. So each panel here is capable of producing 8.39 amps. So since we are doing parallel connection, so which means here we are going to have a negative polarity. So this um, minus, we take it to either of these charge controller. But before connection, we have to connect our battery to the charge controller for the charge controller to get the reference voltage. If you connect your panel to the charge controller, you might end up damaging your charge controller or you confuse the charge controller. Why? Because it is only dealing with either 12 volt, 24 volt, 36 volt, and maximum of 48 volt, for the sake of which charge controller false width modulation. Okay, so since this is the case, how many batteries are we going to use now? Based on our design, how many batteries did we select? Minimum of two, but I know minimum of two because our system voltage is what? 24 volt. But based on our design, how many batteries did you obtain yesterday? No, of course you did that. You got in your own case you got 6. We say we are moving to 8. Why? Because our system voltage then was 48. You were using 7.5 kVA inverter. But in your own case, you used which one? 5 kVA inverter, which is having 24 volts. And the batteries you used there, I think is somewhere around 4, if I can not mistaken. If I'm not mistaken, yesterday, you got, yeah, 4 batteries. I said you can use minimum of how many? 2. Do you get it? In your own case, you can use minimum of how many? 4. So since this is the case, we have, this is 12 volt. This is also 12 volt. Each is 220 AH. 220 AH. We connect them in series to get the 24 volt. Okay, so since we have 4 batteries, this is how we are going to do it. Okay, so now this is series connection, another series connection, then we parallel them. So this is positive polarity. Since we cascade the 2 charge controllers together, then we consider positive terminal from here, positive terminal from here, this is plus, and then we consider the negative terminal to this. This is negative polarity. Okay, so automatically by doing this, the charge, both charge controllers will display. It will show you the status of the system. It will show you the voltage, okay, but no current. It can only show you the actual battery voltage. Since this is 12 volt, automatically when you do the series connection, you have 24, right? So maximum you can either get, let's say 22 or 25 or 26, maximum of 28 as your voltage. This 28 means this is 100% charge in the battery setup. But anyhow, if you get, let's say, reduction of this, let's say you have 26, it is somewhere around 76%. This is 75%. When you have 22, it means you have less than 25%. Do you understand? You see the charging algorithm. When you have 12 volts as your system voltage, okay, so this is how you are going to have this is what we are going to get. Either 12.0, 12.2, 12.4, 12.6, 12.8. So at this is 100% charged. How about here? 75%. How about here? Good. How about here? How about here? Do you understand? So that is why you have to have LVD. When you have your LVD, low voltage disconnect, at 11, you can set your LVD, low voltage disconnect, which means at 11, it is not telling you that the battery, energy in the battery is completely zero, but rather it is less than 20%. Do you get the message? Because if at 12.0, if at 12.5 is 25%, how about at 12 on the dot? 12 on the dot is either empty or let's say somewhere around 10, 15. Do you understand? So how about something below that? You are now about to drain your battery, and if you drain your battery to zero, which means when you charge it, you have lose one life cycle, and it's a kind of problem. So that is why you have to set in your charge controller anytime if I see my voltage showing 12.0, please disconnect. Or let's say it is showing 11, please disconnect. Or maybe it's showing 11.5. You can set it at 11.5. Please disconnect. I know at 12 is not zero. Is 12 zero? It's not zero. Do you understand? If you say, okay, I will let my charge controller anyhow if I have 12 volts, which means you will be deprived from using the inverter. Sometimes you might not get your battery fully charged due to so many reasons. If you rely on grid, there will be an outage. Maybe if you rely on sun, there will be a kind of shading. Do you understand? So which means if like we are using tubular here, and tubular battery mostly if it is tubular, it used to get up to 14. Do you understand? But for this, sometimes somewhere 12.8, it will be 100%. But if you are using tubular, it can go up to 14.0 VDC. You can even have 14 if you are using tubular. 13.9, 13.7, 13.9 maximum of 14. Do you understand? So it depends on the battery you are dealing with. And from there, you can know the algorithm. I just give you an example for you to understand, because you cannot see percentage in your charge controller. Where do you see percentage? It's only in the inverter, where you see the load percentage. Okay, you are now applying 5% load, 6% load, 10%, up to 100%. But for the charge controller, this is all you will see, these values. If you are dealing with 12 volts from 12.0 upwards. If you have 24 volts, when you are dealing with 24 volts, this is how it will be. At 100%, you will have, let's say, 28 V. How about here? 26. How about here? 24. How about here? 22. How about here? 20. When you have 48 system voltage, it will be 58. Do you understand? This is how it goes. All right. So we are now done. What is remaining now is for us to connect our what? Solar panel in the charge controller. So you take minus corresponding minus here, and we take plus. Okay, let me just bring the plus. This is our plus. Automatically, we have connected these panels into the first charge controller. What is remaining is for us to connect the second panels into the other charge controller for us to get balance in the current passing through it. So we have to do the configuration again. 1, 2, 3. Okay, so just like we did to the previous charge controller, we do the same here. Okay, so this is our plus and this is the minus, right? So for the plus, we can pass it through here. And okay, let us have it this way. Minus to minus. Okay, here we are done. So now this, we take it to this very place. Do you get it? So which means this panels is passing through this charge controller, while the remaining 6 panels is moving to this charge controller. And then look at it critically. All the cables from the batteries are connected to both charge controllers. Why? Because initially we have done the cascading of these charge controllers. Plus of this battery terminal is also connected to another plus here. Minus to minus. And look at it. We take the plus of this setup here to where? To very first here. Okay? And the minus is connected here. Do you see it? So as such, the current will be sending energy to this battery. This also current will be also passing through this charge controller and charge the battery. So at the same time, you have done a kind of improvisation. When your current is where is 120, sorry, it's 100 and is it 110 or what was the current initially? 8.39 times 12. Punch your calculator and tell me. 8.39 times 12. 100. Okay, 1.68 amps. And this is the only charge controller available in the market, 80 amps. So for us to improvise, that is why we use two 80 amps charge controllers to what? To accommodate the 100 amps current. So as such, here we will get 50 something. How about here? The same thing. So, which means logically, we were able to improvise the charge controllers and achieve our goal. So, by doing this, you have finished everything. Your system will be charging. What is left now? Incorporation of inverter. Right? And this is it. Okay? Here is the DC part. And here is the AC part. Okay, this is DC part. That is why you see this straight line and dash, 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 dash. While this one is alternating current, meaning it's AC part. Okay, so what are we supposed to do? We still have plus and minus terminal, plus and minus. How do we connect the batteries now? In your own opinion, how do you think we'll do the connection? We have plus here, and then we have minus here. This is plus, and this is minus. So what do? Connect the minus first. Minus first. Agreed. Where are we tapping the minus from? Which battery? We have 4 batteries now. From the parallel connection. From here? So look at it this way. If you want to do an inverter connection, mind you, even if you take it from here, plus here, minus here, it will serve. But I would advise you, if you consider here as your own reference for minus. Take the plus here as a positive. Why? To balance the current sharing. If you only consider, let's say, plus here and minus here, it will work. But these two batteries will be having charging before the down one. How about if you take plus here and minus here? It has to pass through all the batteries continuously. Do you understand? If you don't understand, please ask. Now, our plus, we are taking it from here. What is happening to this? So we are taking our plus from here. How about the minus? From this very place. We are done. Automatically the inverter will come on.
What if we take it from Masa, what if we take it from the middle?
From the middle?
Yes, from
Yeah,
both sides.
suggesting how about if we take it from here?
Yes.
Right?
Yes.
If you take it from here, plus is here, minus is here. This is just a sketch. If you are going to do it in a real life experience, you are going to do your connection. This you take cable from here, this battery
Yes.
to another minus or plus battery.
Yes.
When you are done, you take a cable, right?
Yes.
So now when you are going to do the coupling, that is where I'm talking about. You are not going to cut a cable and do the looping.
Okay.
Rather, you are going to start from this terminal.
From the battery terminal.
Battery terminals.
Okay, I understand.
Do you understand?
Yes, sir.
So this is what I'm saying.
Okay.
So you have to look at your last terminal of your battery.
Okay.
Take your negative, and then from off you take the positive.
Okay, I understand, sir.
Because this is only cabling. It's just a connection.
Yes.
Uh-huh.
I understand.
All right. So now we are done. This is only in the case of PWM charge controller. Okay. How about we want to consider the MPPT approach? MPPT approach this is the charge controller MPPT. This is the capacity to it, 120 amps, MPPT, okay? So now, how many terminals does this charge controller has? It has 4 terminals, but some MPPT charge controller has 6 terminals as well, okay? But basically, the 4 slot charge controller are common, okay? So you have plus and minus. This represent your what? Your PB. Do you see it? And then you have minus here and plus here. This represent battery. I believe you might have a question here. Why here we have plus and minus, and then for the battery we have minus and plus? Because MPPT charge controller has what is called wide range of open circuit voltage, which means you have a higher voltage. Okay? Even though it has system voltage, of what? It has system voltage of either 12 volt, 24 volt, 36 volt, and lastly 48 VDC. It has system voltage of either 12 volt to 48 volt, but it has a room for why it has wide range of open circuits. So as such, when you are having high voltage from your solar panel, and then coincidentally it collides with the battery terminal, what do you think will happen? There will be a feedback. There will be a clash. Do you understand? So as such, to prevent that, look at it. The negative polarities are sharing borders, whereas the phases, which is positive polarities, are away from each other. So, and it is the plus that is carrying the power, while the negative is just a kind of support. So as such, this is the reason why they consider it this way. So since this is the case, how many batteries do we have? We still sketch our batteries. We have 4 batteries. Okay? 12, 12, 12, 12. Okay? Plus and minus, plus and minus, plus and minus, plus and minus. So this is, we do series connection here, series, then we parallel them. How do we parallel them? We consider this plus and connect it to the second plus here. We consider this minus and connect it to the second minus here. What are we achieving here? Automatically here, we have achieved what? 24 volts, which is our what? System voltage. And then by connecting this, okay, mind you, and we have 220 AH. Each battery is having 220. But since we do series connection, the voltage will be added, and it has been added. Initially it was 12, but lastly when we do the series, we got 24. But the current will be constant. It will be maintained. What did we have? 220. Fine. So the same thing here. Okay? But since we do the connection here, the same thing here. 24B to 20AH. But because of this connection, minus to minus, plus to plus, now the current will increase while the voltage will be constant. What are we going to get? We're going to have 220 AH plus 220 AH, and it will give us 440 AH. But what is the voltage? 24 B DC. We are done here. What are we supposed to do? We connect our battery first in the charge controller before that of the solar panel. So what are we going to do? This is the battery connection. So minus is here, okay? And the plus will be here. Mind you, even if you do this, the charge controller will not display anything. Why? Because it's not as PWM. It is only PWM that if you connect your battery terminal to it, it will display. But this one, don't be panicked, it will not show you anything until you connect your what? Your PB input. What are we supposed to do? But mind you, before doing this connection, we have to consider the protection. Where is our plus terminal? It's here, but okay, we have a breaker. Do you understand? We slot in breaker. For what? Protection. In case if you want to do maintenance or there is any problem along the line, it will trip up. So this is a protection. Breaker. Do you understand? We are done here. Okay? We have breaker here before connecting it there. So we are done. The same thing for the panel. Okay, we have plus and minus. So how many cables do we have for the solar panel? Here we are going to see a different approach. How many panels do we have initially? 12 number. Okay, here we separate them, 6 here, 6 here. First 6 move to this charge controller, the second 6 to the second charge controller. But in this case, we're only having one unit of charge controller. So as such, can you remember I've told you it has a wide range of open circuits? So the wide range here is 195 BDC. Sometimes it's ranging from 175 to 195 VDC. So let's take it, we're having 175. Can you remember your open circuit voltage for the solar panel? 36 point something. 36 point what? Check. 37.6. Okay. Okay. So our open circuit voltage is 37 point what? 67 V. So which means since this charge controller has a range of minimum of 175 and maximum of 195. So okay, fine. If we connect connect 3 panels in series, what are we supposed to get? 37.67 times 3. What do we have? Okay, it's not up to here. Times 4. Times 5. So if the charge controller you are dealing with is 195, which means we can connect up to how many? 5 in series. But if it is 175, we connect only 5. While we are obtaining what? Okay, it's 4. Good. So we are stopped, which means we have how many panels in series? 1, 2, 3, 4. Okay? 1, 2, 3, 4. Okay? Here we have plus and here we have minus. Plus, minus, plus, minus, plus, minus, plus, minus. Okay, plus, minus, plus, minus, plus, minus. Okay? We are done here. Then we'll do for second one. 2, 3, 4. 1, 2, 3, 4. Okay? How many panels do we have now? 12. Good. We do series, 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 series. Lastly, we have parallel. Do you understand? So we take this plus to plus here, and we take the minus to minus here. We are done. Do you see the differences? In this setup, we have matched about 4 panels in series. When you connected these panels like this, what do you think will happen to the charge controller? Because each panel is 24 volt, 24 plus 24 plus 24 plus 24. It has exceeded the limit of this PWM charge controller, which is what? 48 volts. Even if you connect 2, that is when you have 48. When you have 3, it has gone beyond its limit. But for the sake of MPPT, look at it now. We connected 4 and all is well. Do you understand? So that's why I said we have different approaches of dealing with this setup. Do you get it? So this is it. Is there any question?
In the connection,
Yeah.
while connecting the battery to the charge controller, we said we are going to use breaker.
Yes.
So the breaker, are we connecting with the only positive?
Yes.
Or with the
You have a choice. You can decide to take only positive. You can decide to take both positive and negative.
Okay.
But even if you take positive, if the positive is not the circuit from positive is not closed, nothing will happen. The essence is for you to have protection in case of either maintenance or maybe there is short circuit elsewhere. It will only trip up, so that the circuit will not be complete. So that if that is the case, there will not be any problem. So this breaker is just serving a kind of protection purpose, not more, not less. We are not connecting this to maybe another component. Rather, before letting this cable enter charge controller, we just have a kind of protection. Like in your house, after you enter in the main gate, what do you normally used to do? You put padlock, your keys. You can also enhance security approach. Okay, like maybe you go for electric fencing wire and what have you. Why? You want enhanced protection in your house, right? The same thing here for safety purpose. Okay, so for the panel 2, we need to have a breaker as well. So we have breaker here. Okay, we have breaker here, and this is plus terminal and this is minus terminal. Do you understand? So this is it. Any question?
So,
Okay.
this BMW setup,
Mm-hmm.
are we supposed to connect the inverter for the panels? Which one comes first? I understand that we have to connect the batteries first.
Yes.
So, which comes first?
Okay. After the reason why I said you connect your battery first before the panel is for your charge controller to understand the reference voltage. But you can decide to even connect your panel in this setup before connecting the inverter before connecting the panel. That one is not any kind of issue. You can decide to say, okay, I have to connect my panel in the charge controller for the battery to obtain charge before connecting my inverter, because inverter is just a kind of end user. Do you understand? It is only it is only tapping from the wire battery. Are we tapping our inverter to the charge control? I mean, to the solar panel? No. Rather, we are collecting energy from where? From the battery. So if you take it battery to charge controller, then inverter to battery, no problem. But preferably, finish your setup to see that the charging is moving, your battery is fully charged before tapping out energy from it. Yeah. Yes.
This, as you said,
Yeah.
BMW, there are 6 inputs
Yes.
for the panel,
Exactly.
battery, and the load.
Yes, yes,
So
yes.
on the MPPT, we're having only 4 inputs.
Exactly, for
the
inputs.
panel and the battery.
Exactly.
So how are we connecting our loads to the MPPT?
Okay, fine.
Yeah.
You are referring to the load connection. Here in the PWM approach, this is panel, plus and minus panel, plus and minus battery, plus and minus load, which is what DC load. Mind you, what load do you normally used to apply in your house?
Load, AC
Yeah.
load.
For DC load, I'm referring to DC load.
Okay.
What is the voltage? Mostly 12 volts. You are referring to like maybe a ceiling fan. We have AC, DC fan, right?
Yes.
It's 12 volts. Okay. What else? Bulb is also 12 volts. There is a special case when you have a bulb of 24 volts, but mostly it's 12 volts. So now, if you can remember here, this charge controller is capable of taking what? 12, 24, 36, 48. But mind you, the system voltage you're operating here is what?
24.
Is 24.
Yes.
If you connect maybe plus and minus from here and tap it to your DC load, which is 12 volts, what do you think will happen? You are bound to damage your battery
Yes.
because you'll be having unnecessary energy out of it.
Yes.
It's a problem. What are you supposed to do? You use what is called DC to DC converter. This is how it is. This is DC, and the output is also DC. Input, and this is output. So input, even if you are getting 48 volt here, the output will be 12 volt. So from there you can tap your load. So what are you supposed to do? You take it from where? From the battery slots. It can take 12, it can take 24, it can take 48. Do you understand? So it's just a kind of converter, DC to DC converter, for the sake of MPPT. I hope I've answered your question. Great.
sir. So that means this converter, we connect it. Yes, we connect the terminals to the battery terminals.
Yes.
Yep.
In the case of this
MPPT.
MPPT, exactly.
Yes, okay.
Yeah.
Okay, so but in the case of this PMW,
PWM.
yes, in this case where we have
From-
two, yes, where we
Okay.
have two charge controllers.
You have to charge controllers
Yes, how
here.
do we connect the load?
Okay, look at it here. Here, what is your load? It's also 24 volt. Do you understand? It's also 24 volt. Why? From the battery here. This is 24. We are sending in 24 volt in the both charge controllers. So in any case, you have to use the converter. But that is why most of the installation is failing. They will go and do neat installation, and then they will discover that the system voltage has exceeded. Then they will tap from one of the batteries, and that is why that battery will not last longer. Yes,
Connect their load electricity.
to one either of the battery, either first battery or second battery or third battery or fourth battery, and there will be a kind of crisis. Yes, but when you use the converter, that is where you will not have any issue.
So in any case, you have to use the converter.
In case if you are not dealing with 12 volts. But if your system voltage is 12 volt, automatically you don't have problem. Where are you supposed to tap from? From this load terminal, either this one or this one. Just close.